Alright, with the scariness of a viewing system and then especially the save system behind us, let's do something a tiny bit more fun. I want to just go through and make a handful of different types of objectives to gather up. So this is going to do two things. Number one, just show you how to set up an actor with a delegate on it that you can bind to that isn't provided you by the engine. And number two is I want to look into making our tasks a little bit more complex to be able to handle tasks that have progression to them. Because right now we only have tasks that have a concept of, hey, I am finished or I am unfinished. But what if we want to have a task that has a certain percentage of potentially being finished? So let's take a look into that. The first of which is I'm going to make this something like a stand-in for an enemy. We're slowly starting to grow out of proportion with the amount of blueprints that I have within this project without sorting anything to folders, but we'll be fine. I'm just going to make this BP enemy, and the enemies are going to be cubes because I don't really think that we need to go over modeling entire enemies and making an entire combat system. That's super not the point here. These are going to have an event dispatcher called something like onKill. Just for the sake of making this flexible, I'm going to add in here an input for the enemy type, and that's just going to be a BP enemy class reference. So if we have multiple different types of child classes of this enemy, it'll actually send through what type of enemy was killed. If you have a specific task to kill a specific instance of an enemy, that's something that we can do. But we can also make it so that you need to hunt down a specific amount of a specific type of enemy. So we're going to make tasks to do both of those things. But let's say that we just have a custom event here for kill enemy. That's first and foremost going to call out its onKilled event with a reference to self. You can just put that in here, or you can't actually do that. You need to get class from it, and then you can put that in there. That works as well. And then we will just destroy this actor. Now, in order to kill these enemies, I'm still going to make them just when we overlap with them, they're going to die. So it still will be kind of like a location event. But of course, if you have a combat system in your game, you would tie this into when you attack an enemy and its HP is under 0, it calls this kill enemy. For now, we just do is a soft third-person character kill enemy, right? Which means that we also need to add something like a sphere collision or something at least somewhat similar to it. So we can put these in the level now, and if we walk up to them, they will die. But let's make a task that looks out for a specific enemy to be killed. So we can go back into let's do in quest number 1. We have an objective to go to 2 locations, but we'll also now make an objective which create basic objective is going to be its parent, STT, kill enemy. Which is going to do something similar to the other things that we did. Instead of making a new function, which I did by accident, you're going to go enter state, you make a variable for enemy to kill, which will be a BP enemy reference, and you simply just assign onKilled, at which point you get the task, or you get the objective rather, this task that we have here, and we finish that objective. Quite as easy as that, really. So now we can go back into quest 1 and add a new objective here. So we can get a kill enemy objective, which do make sure that it is above the objective manager, because it might start acting weird if you create it afterwards. We're going to be adding it to the objective manager, so we just add a new index here. That's going to be STT kill enemy quest objective. Name is kill the wolf. There's no wolf there, just a cube, but let's just pretend like it is. You add a parameter, and this parameter is going to be of type BP enemy. Object reference, we generate a task ID, that's important. And then don't forget to set the enemy to kill to being an input. That's something that is easy to forget, but it needs to be an input because otherwise it doesn't show up here. Go to parameters, new property, probably give it a name, like enemy1. And make sure to call parent function as well. That is, again, another thing that's easy to forget, but you do need to do that because the parent function is actually the thing that sets up this quest objective object. And now you can see, if we go into the world, and I open up the quest, we now have walked to location 1 and 2, but also kill the wolf. So if I now go up and kill the wolf, we'll have killed the wolf as part of this quest. So that's number 1. Now, task number 2 would be keeping track of how many enemies we have killed of a certain type. So let's actually make a couple of different ones here. Let's actually not delete this first one, that's fine. And then BP enemy, we're going to make a child blueprint, and that'll be BP enemy child 1. And we'll change this to a different material maybe, like this one will be grey. And we'll make a BP child number 2, which it automatically names properly. That's fantastic. And that's going to have yet another material. And this was just going to be entirely black. Why not? So then, now that we have a couple of different ones, what we can do is I can go back here into my blueprints for my third-person character. And what we're going to do is I'm just going to make a custom event here real quick. Kill enemy, which is going to have an input of type kill with a BP enemy class reference as the type. And then we'll also make an event dispatcher on kill enemy existing on our player character. That's just kind of going to forward that to whoever is listening. So we just make this new param, enemy type, and whenever this killed enemy is called, we just forward that information to whoever is subscribed to this event dispatcher. So now in our enemy actor, instead of just killing the enemy like this, what we'll also do is we will get the other actor. And in this case, we're actually going to need to do a cast to third-person character, because we're going to call the kill enemy with our class reference to self. And then we'll actually do the kill enemy still as well. So now let's go back in here and again make a new task, create basic objective, and this will be STT kill enemy by class. We'll override enter states. We'll call the parent function. In this case, we'll just get the player character, cast it to a third-person character, and then assign on killed enemy, which I also misspelled. Just ignore that for the time being. Whenever we do that, we just check if whatever we killed was of a certain class, which we're going to promote to variable class to kill. Now, this is going to be a object by default. We're going to change this to specifically a BP enemy class, so that's a little bit easier to pick out. And we kind of just set that to being exposed. And if the thing that we just killed is the class that we're looking at for to kill, we get objective, which is down here somewhere, and we finish objective. So it can really be as easy as that. So now let's add in yet another one of these, kill enemy by class. We'll say kill the grey one. And I think it was enemy child number 1 was the grey one. Yes. We'll give that task an ID. Make sure that it happens before the manager task as well. And then in the manager task, we add in a new task to look at, kill enemy by class. And now that should be added as well. We don't even need to add anything to these parameters because it's just looking at the player itself directly, and just every time the player broadcasts, hey, I just killed something, it's checking, hey, did you kill the thing I care for? If so, we're going to be moving on. So it is actually even easier to set up than most other things. So if we now do this, we can see we have killed the grey one. If I kill the black one, for instance, it doesn't update either of the other ones. If I kill the white one, that's referenced by instance, so it kills the wolf. If I kill this grey one, it kills the grey one. But let's say that we have another grey one over here. Because we're not referencing a specific instance, but we're just checking, hey, the class that we killed, is that the grey one? I can kill this one, and it works all the same. So of course, the next evolution of this is to make this a variable on how many we need to kill. And for that, we do need to go back and change a fair few things here. So let's take a look at that. The very first thing that we're going to need to update here is the quest objective itself. We'll see here the progress for this objective. and we'll make that a float. This is effectively always going to be a 0 to 1 value. Finish objective is going to stay the same, but we're also going to make a update objective instead. And when we update the objective, what we're going to do is we're going to set our progress to a new progress value. So this will be, let's just call this new progress. And if this is now greater than or equal to a value of 1, then we will finish the objective. So we're never going to be calling finish objective anymore directly in any of our state tree tasks. We're just going to update the objective, and then update objective will take care of, hey, do I also need to finish this? The only real place that we need to start updating is location objective. Obviously, that's always going to be a 0 or 1 type of deal. The kill enemy by class is the one that we're working with. This is where we need to start looking into, okay, when we kill an enemy, instead of just finishing the objective right away, what we need to do is we need to keep track of kill count, and that's going to be a integer. We just pull that in and we increment that whenever we kill something that is the right kind. Then we also make a new one for amount to kill, which we will make instance editable. We'll expose that. And then here what we do is we get our kill count and our amount of kill that we need, both. I'm going to do a to float for both of them, just because we're going to be dividing them to get a decimal, and it's easier to just convert them to a float to begin with there. And we take this amount of kill that we need, and we divide it by the kill counts that we get, and this gets us a 0 to 1 value of how much progress we have made. So we just update objective with that new progress. And we don't need to do any of the finish objective logic in here because the object takes care of that for itself. So now if we go back into quest 1, kill by class, it should have an amount to kill. Let's set that to 4. And it's only going to increment that when we kill the gray cubes. So let's add a couple more gray cubes just to show you. So I'll just put 4 of them here back to back to back. We pick up the quest. It has killed a gray one. Well, it's actually 4 of them. Now, if we interact with this, it already does seem to be finishing it. Don't listen to what Past Me said. Past Me is very annoyed with all the noises going on outside. You need to turn this around. So you divide your kill count by the amount that you've killed so far. I did it the wrong way around before. So now we should be able to see, we pick up the quest, it says kill the grey one as one of the objectives. We kill 1 of them, nothing happens. We kill 2 of them, nothing happens. We kill 3 of them, nothing happens. We kill 4 of them, it's now crossed off as being done. So it's counting up toward whatever amount you need to do in total. So from here on, you can do that with items, with these enemies. This honestly is closer to an item pickup system than an enemy killing system, obviously. We just need to be able to save and load that data along with whether or not the task has been finished in general. So for that, and maybe be able to display it as well if you really care about that, which you probably do. But let's open up our task status save here, which has our boolean and our GUID. So we're just going to add in a progress value that is a float. Open up our objective manager class here, and you can see now we have this set progress value. So whenever we finish a task, that obviously means that we set it to being a value of 1. And if we're going to do this, we do need to also update it anytime the value updates. So we do need to go back into our quest objective itself and make a onUpdated that we need to call out. So we do onUpdated, which is going to have a input parameter for the objective. We could also just push through only the new progress float, but in case we have other information to update down the line, it's better to just push through a reference to the object as a whole, which is of course going to be our quest objective reference. So we call that with a reference to self whenever we have updated this value. Now, going back into the objective manager, this is when we finish the event, we do all of this. So now what we do is we also bind on updated. And what we're going to do is we're going to kind of replace this, to be honest, because we don't really need to do any of the objective finished anymore, because we're going to update all this whenever the objective gets updated to begin with. The value progress we're going to get from this objective as well. So task ID, we also get finished state on whether or not it's now finished, and get the progress. At this point, it might be good to start like organizing the blueprint a little bit better, because it is starting to be fairly messy all over the place. But this will take our current object values and put it into our save array. And then we're going to have our update event bind to that, and we're just going to get rid entirely of the objective finished event dispatcher. And since we do that, we do need to make sure that we call this on update at the very end of this actually. So we first do our check, then we finish objective, and after finish objective, we call the on update. And if we don't finish objective, we just call on update anyway as well. So now is a good time to test out whether or not that still works the same way. So we pick up the quest, kill the gray one, 1, 2, 3, and 4. That still works. The other ones also still work. If we kill the white one, there we go. If we go to our location, that also still works. So everything still works the same way, except that we're now also saving our progress values on this. The only thing left to do is to also load those values, and that's what we do over here. So we set our task finish to whether or not our task was finished. But we also use this exact same object, which is a object from our objectives array, to then set our current progress. And the way that we're going to get that current progress will be from this task ID already in save progress, because right now we're only returning whether or not it was finished or not. What we're going to be doing instead is I'm going to just return the entire struct. So we're not going to be using was finished anymore. What we're going to do instead is I'm going to disconnect everything about this. I'm going to recombine this structure pin, and we're going to just put that as one of the return pins. Then we'll also add in a break node for it, because we still want to be comparing this ID, of course. And then was finished we'll also get rid of, because we're going to just, again, send through the entire struct. Makes it a little bit more future-proof, because if we add more stuff to this struct, I'll just send through the entire thing. So was finished will disappear as well. That doesn't matter anymore. We just pull this thing out, we break, we set our status, and we set our progress like this. So this is the loading side of the entire setup. So now that we have that, we just need to go back into our task that keeps track of doing those enemy kills, because that's going to require a slight change. So where before we were dividing our kill count by the amount to kill, what we're going to do instead here is we get our amount to kill and divide 1 by that amount, and then we just get our quest objective's current progress and add those two together to get our new progress, because that way is going to be adding a 1 over x portion to whatever we already have in there. And now you'll notice that if I start the quest, we have the quest, let's say I kill 2 of these gray ones, I save, I back out and I start again with loading. Quest isn't completed yet, but if I kill 2 more, now the quest is completed, because it also saved my progress between play sessions. So with that, you can now effectively set up the quest however you want. Get this amount of this item, kill these specific instances. Whatever you want to do for your quests, you effectively now should have the tools to script out and program effectively any sort of objective that you could think of. And because this is all related to assets, I might add, the only thing that isn't quite related to the asset as far as identifying these quests goes is the GUID on the quest giver actor itself. But if you just copy that over to another instance of this in another level, progress for these quests can very easily just persist between levels. If you want to have a quest that's given in one level and has an objective in another level, you can just copy over the GUID and the stage tree itself and populate one of these parameters in an entirely different level. And then when you come back into this level, it should have pretty much all the progress saved between different levels as well. As a fair warning, I haven't tested that very thoroughly with this system, but there shouldn't be any reason that that necessarily would mess up, as far as I know. If you want a more in-depth and slightly more flexible system in some ways, I still do have the object-based one, and I honestly do think that if I were to go ahead and make quests for a game, this is a lot more readable in a lot of ways because it's using the state tree interface. I think I would personally use the UObject-based one that I made before because of its flexibility and the way that it can infinitely nest stuff, and it's really quite neat, but it is a bit more complicated to set up. So if this does what you need it to do, it's a fine system if you want to dive in a little bit deeper and create something a little bit more semi-advanced. I think that this is still a good step up, getting all of this to work, making you understand how these UObjects, the basic objects that we're working with, work. And if you want to progress to the UObject-based quest system that I made in the past, this will be a good lead into that anyway. So hopefully this has been a helpful thing. The entire series project files, of course, will be down below in the description as always. And next time we'll be back with something else, a lot of fun. I think for the time being, we've had a lot of state tree fun. I think we're going to do something a little slightly different. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Mauricio Farias, and my Cave Student tier supporters, Oiku and Earl Monsville Urno.